Okay. Good morning. Let me know in the chat if you guys can hear me, and I'll go ping the Discord. Hey Astro, how's the volume? Can you hear me all right? How do I get this link? Sounds good. Cool. Okay, just notified the Discord. Let me get this set up, and then we'll give just a couple minutes for people to trickle in. I need to do some of this. Hey Stefan and Endcraft. Okay. All right, I guess I'll just jump in and get started. So we had made read char, and now we're trying to make read word, which accepts a buffer address and size, which we already did here, right? This is the buffer address and this is the size. And then it reads the next word from standard in, stops and returns 0 if word is too big for the buffer specified. Otherwise, returns a buffer address. All right, that's not too bad, I don't think. To be honest, I don't get what read word should actually do. You mean like when I actually try to use it in the command line? I think, remember how like when I did read char, it like waits if I enter something and then hit enter, returns it. I'm thinking it'll be like that, but if I enter a word, it'll return it instead of just the first character, unless it's longer than the length, then it'll return 0 instead. I think that's what it's saying, but I could be wrong about that. Okay, so we need some sort of loop, right? How to set this up? Just wants you to read a string and then use print string on it. Yeah. Hey cat. I don't know that it didn't specify to use print string on it. I think it says to write it into the buffer, right? So we get a buffer address. We're supposed to write it into here. So I need to, okay, so I need some sort of counter. So we'll like use RAX maybe. So let me copilot disable. Cool. And then I'm a little quiet. A little quiet. I mean, I have the mic turned up all the way. I can move it a little closer though. How's that? Is that better? All right, so zero out our counter, and then we'll make a loop, something like that, and then cool. Something along the lines of yeah. Except that's not assembly code. But yeah. So well, where does rechar puts it in RX, does it? Rechar. Yeah, okay, cool. So rechar sticks it in RAX. So if I were to rechar here, now, okay, that's bad because we're actually using RX as a counter. So we should probably use a different register as a counter. But I always forget, what register do we use as a counter? There's so many registers. Let me get a new browser window up here and pull up this guy. Doesn't really say. What register in NASM should I use as a counter? RCX? This recommends RCX. One of these ones? Let's use RCX because I'm not using that yet. All right, so we'll use RCX here. Does that have a special? It's the fourth integer argument. Okay, that's it. So we use RCX. So initialize counter get a char. All right, so we have a char, and well, maybe first we should check here that we're not past the size of our buffer, right? Which is in RSI. So we're going to compare RCX with RSI. And then jump if equal, right, to I think that's what we would want. Jump if equal to the end, which would be here. This is gonna have our return statement in it. Check to see if we've hit the size. If so, yeah, well, this is obvious. Okay, jump to the end there, and then all right, so then if we haven't, then we get a char. Or maybe I should call this too big, right? So this is, I'll call this too big. Multi-cursor doesn't work on this code space for some reason. All right, jump to too big. So if it's too big, then we want to return 0, right? Or what do we do? Yeah, stops and returns 0 if the word is too big for the buffer specified. Otherwise, returns a buffer address. You should consider dot label with a dot for local labels. If you put multiple functions in one file, you can only use loop once. But you can use dot loop in every function. Oh, I didn't know that. Sure, like this. So we need to return 0 here, so we'll move as, or I guess we can just do it this way. RAX, and then return like that. Here we call rechar. Okay, so now we have a char in RAX. Now we have a char in RAX. We need to write it into the buffer. So how do we write things into memory buffers? With move, like word buffer. But then I would need to like offset it, right? Do you need this? I'm not sure about that. Next 64 NASM, how can I write a value from, or move a value, or I guess, yeah, right, a value from a register into a, into memory declared in the .data section. Yep, so this is like that. Like this. Oh, that's so it's kind of like what I had, no? Okay, so it is like this. But we need to offset it, right? So, and can we specify that we're just moving a byte? Doesn't that go there if you're just moving a byte? I think. I'm not sure about that. And then this gets an offset. Offset by... Is that how it works? Or am I totally making this up? Our counter. I feel like I could be really wrong about this. I know he's just learning right now, but is Kai planning to start the OS project by writing a bootloader for a floppy disk image for a virtual machine? I don't know about the floppy disk image, but I'm writing a bootloader. I'm going to write a bootloader. Seems good to endcraft. Cool. So I didn't make this all up. And then then we have it in here, and then we want to pretty much repeat, right? So we'll increment our counter, inc rcx, and then continue. That might work, I don't know. We'll find out. And then down here, what was I thinking with all this? I was putting a new line, then I was printing, oh, this was if it returned 0. I was going to print the 0. Okay, let me comment that. Print 0 if it returns 0. Otherwise, we got to otherwise return a buffer address. So this isn't quite right, because I need to, so if I have something that's like if my size is like 8 or something, and then my text is like lorem, that's like 1, 2, 3, 4, 5, 6, 7, 8, right? If this is my string, then it should get this without going to too big and return the buffer address to this thing. But if it was this, then it should return 0. So I haven't handled this case. Right, so somehow we need to stop in here. So we compare the size. So when will those be equal? Because I'm starting at 0. Starting at 0. And then, okay, wait. So I'd start, let me just run through this code real quick. Isn't the stop? Yeah, that's what I'm kind of confused about too. What is the stop condition? Oh yeah. Oh, I forgot about the whole skip whitespace thing. We still need to skip whitespace. Yeah, I know. If it were read word, it should stop at whitespace. But it's just saying like read however many chars you tell it to and skip the whitespace, right? So that's kind of weird. All right, these down here. These are the codes for the whitespace things we need to skip. So I need to check against all of those. Maybe we should be running these Python tests that were. Didn't Igor send like an updated? He sent this. See, this is updated. So this is the updated one. Because this is using Python 3 now. Oof, should we try it? Endcraft has to go. Okay, thanks for the help, Endcraft. See ya. All right, I think I'm gonna give these a whack because this will at least make me adhere to the instructions. It might even expose that we failed on the other assignments. Let me bump that over there, and then okay, so we'll go. All right, assignment 1. Let me make a new thing here. It's like, well, I guess here. My phone on do not disturb. Okay. Let's all right, I'm going to git clone. What is this? Oh dear. I can't clone from GitLab. I mean, I could set up SSH, or I could just copy pasta the files. Why clone through SSH? Do the HTTP? How does that even work? I've never done that. Git clone like that? Bro, who knew? Stefan, you're a hero. I literally didn't even know you could do that. All right, this has now like a git sub repository, which is kind of annoying. Can I just delete the .git and make it not one? Okay, thank you. Now if I, maybe not. Okay. So this is some PNG. This is getting ignored. We can get rid of that. Get rid of that. README. This is not English. We'll get rid of that. Ooh, I like how the comments are in Russian. This is cool. This is cool. Hey, you know what? If I turn Copilot back on, oh, check it out. It translates it for me. But let me okay, keep translating Copilot. Ha. We're doing it. Well, this is a lot. Wait, how much of this is actually part of it? How many lines was this? This was 1, 2, 3, 4, 5, 6, 7. I got 1, 2, 3, 4, 5, 6, 7. This one's baloney. All right. And then this becomes cool. Almost there. Who knew we'd have to translate Russian? Cool, and then no, that last one was made up. All right, worst comes to worst, we have these two. I guess I didn't really have to do all that, but it was kind of fun. So now let me just get rid of that and get rid of this. Oops. Okie dokie. So there's that. We need to fill some of these in. So we never did this exit one, but I'm thinking this is pretty trivial, no? Takes return code and terminates the current process. So return code probably goes in RDI. So we'll just move REX 60, and then RDI already has the thing, and then we just syscall, and then we return. Right? That should be good. Or maybe we should try writing the test first before we do anything. So this now is using Python 3. Do I have Python 3? Sure enough. But that's not going to be the same. Wait, what is my home? It's home code space. So this is different. Yeah, okay. I'm lost. CD. Okay. So Python 3 was this. So let's copy this. And then we'll stick this here. Cool. And now hey, Bacon. Guess what? We're trying Python again. Invalid escape sequence. What does this even mean? Maybe it's all explained in this README. But I can't read this README. Hmm. Anybody out there know Python and know how to fix this? Importer cannot import name text test result from unit test. Stefan's saying, let me see. Mr. Nibbles knows of Python. Did I mean this? Did I mean this? Text test result. It's not even in here. Shouldn't have to modify anything inside the Python file. Okay. Sudo apt install Python 3. Already the newest version. You need to either modify the regexes so that it has // d, or have strings like that. Notice the R in front. You mean in the Python? So turn all of these into that is what you're saying? That's it. There's only those two. So try that. Different error, right? Fewer errors. No module named unit test 2. How do I install it? I literally know nothing about Python. I've never once written a line of Python. Is there some sort of like... Oh wait, isn't there like a... this? Apt search unit test. This Python unit test 2. This looks promising, doesn't it? So I have it. So sudo apt install. Sudo apt install Python 3 unit test. Is that what it was called? No, it's just Python. It's not Python 3. Is this okay? This one? Oh no, there is this one. Python 3 unit test 2. I think I tried that. Oh, Python 3 unit test 2. There we go. Cool. Now if I run this guy, still says no module found unit test 2. Now do I need to do this? I guess it's not a binary. Sudo apt install python unit test for good measure, you say? That one doesn't exist. Python 3 unit test? Or Python unit test 2? Python unit test 2. Well, maybe we shouldn't use the Python. Oops, sorry. You said do which, oops. Which Python 3 unit test 2? Yeah, it's not. Where can I find the repo? See if I can fix it here. It's right here. All right, well, in the meantime, I'm just going to, just for the sake of keeping things going, I'm just going to skip read word for now because I'm a little bit confused on the requirement. And to keep going the way I was going over here, and just jump to parse uint because none of these depend. This doesn't depend on either of these. This doesn't depend on either of these. This doesn't, and this doesn't. Yeah, so none of these depend on these two. So I'll just try to work through these just to keep going with assembly. So I don't want to waste any more time on learning Python. Okay, so parse uint dot asm. It's gonna look like global start, and then we'll have start inside the section.text. Just clone and installed unit test 2. What? Wait, let me try to reproduce what you just did. So you're saying you cloned this. Let's try it. Let's try it. I'm gonna git clone this. Boom. Now I have it right here. Okay, and then you said what did you install exactly? The same one I did. Sudo apt install. Which one? The Python 3 unit test 2. Okay, until we hear more on that, I'm going to keep going over here. What? Work directly for you too? If I go into here now and run test.py. Hey, like this? Whoa, this is awesome. I literally didn't do anything. I cloned it here, and then I just CD'd into it, and ran the Python script. What are all these? Good grief. Were these all generated by the test? Did you guys get these too? All this? Did it all get ignored at least? Yeah, okay. Good griefers. Okay, so it's working. It's working. So we can get rid of not that, but this. Okay. Hold on to this because I'll copy those over. Yeah, the generated, okay. Alright, I'm gonna make this yet bigger, and then oh dear, this is bad. Sorry. Alright, open this guy up. We still have our Russian comments, but that's okay. We can just, get rid of them. Or just keep them. They look kind of cool. I like how the Russian looks. Get ignored. Yeah, they're get ignored. Okay. And then we'll copy over. Well, let's open up a terminal first. Terminal. CD assignment 1. Okay, and then we do the test, and it all fails. Okay, cool. So then, I'm going to need to do something. So the exit one we said, so it takes a, right, because in English this is terminates the current process with the given exit code. So there's going to be an exit code in RDI, which is already where it needs to, right where it needs to be, right? So we could just move into RAX 60, switch this to a move, and then RDI already has our thing. So that would be excessive, what Copilot is suggesting. Actually, I kind of want Copilot on. Look at read word in the test output. Maybe it gives a clue to what it does. Yeah, I will. I'm just going to fill in the ones to try to clean up that, because everything's failing right now, right? So I'm just going to fill in the ones I have done first. And then syscall, right? And then return, I guess. I don't know if you need to return after an exit syscall, but oh well, it won't hurt. I don't think. This in English, well, we have our book. String length. So we wrote this over here. What did I call it? Strlen. String length. I did it like this. Okay. In English. Looks like this. Takes a pointer to a null terminated string and returns this length. Okay, there's string length. See, I wonder like if that one's even passing now. So we should try this. Wait. Oops, I should turn my brightness down. So like what are these saying? Like parsent failed, obviously I haven't written it yet. These are all out of order. See, why isn't it showing all the tests? Where is it? Like is print string in here? Probably only reports the failing ones. That would make sense, but it's not even, this one's surely failing, right? And it's not showing print string, is it? Why didn't my grep work? Oh yeah, print string. Oh, it is testing. Okay. Okay. Cool. So then print string, this in English is, there's no way that's the only thing it says. I'm not getting help. All right, that's all right. We know print string looks like this. Is that it? And then print char looks like this. Printing on standard error while grep handles only standard out. That's interesting. I didn't know that. All right, print new line. We also have somewhere. Looks like this. Print uint. That's parse uint. Where's print uint? Here we go. Oh yeah, this one is complicated. Print uint. Looks like that, and then we have print int, right? Yeah, print int. This one was also complicated, but it depended a lot on the other one. Print int. Print int looks like that. String equals. Whoa, this one's different. Wait, string equals wasn't in here. So this must, oh, it is. It's down here. Because there's a little bit out of order. String equals, and then read char, read word, parse uint, parse int, string copy. Okay. So let's try running these tests. Let me give myself some more room here. Okay. We don't need the grep. All right, 15 failures. Work from the top. Oh. What are all these horrible errors? Good grief. Symbol stirlen is undefined. Oh. Stirlen. Oh, you already commented about that, Astro. It calls stirlen, so rename that. All right, stirlen. Sorry. Let's try that again. You do not respect the calling convention. Check that you align stack before call correctly. Oh dear. Wow, that's kind of cool. That makes sense, actually. Who would have thought? No. Don't change the string length name. Just the calls. Oh. Smart. Okay, yeah. Stirlen. String length. That's the only spot. Okay. I see what you're saying. I see it. All right, so we didn't respect the calling convention. Not sure what that means. And then test parseInt totally failed because we hadn't written it. Test print string also failed, and we did write it, so that's not good. Yes. Yeah. You need to do this for all your calls. Are my other ones all messed up too? Are the other ones messed up too? Sounds right. Sounds right. Sounds right. Sounds right. Sounds right. Yeah, I think these ones are good. Okay, so this like print string, assertion error, this doesn't equal that. Printed the wrong string. Hmm. Okay, so we need to fix some things. Test print string. Can you run your independent print string? Yeah, I was just gonna try that. Like, just run it on my own. Is that what you mean? I need to make like a little thing here though, right? Like a global start maybe. And make a start here. No? That's not what you meant? Oh, go to my standalone guy. Look in the folder where your lib asm resides, and you'll see all the executables. Oh. Okay, Stefan is right. So I got executables for all of these things. So what if I ran like print string here? It says you do not respect the calling convention. Okay, so you're saying jump over to where I have it alone. Yeah. Okay, so print string this guy. Print string, where are you? This guy? And then says hello world. If I were to change it, like am I trying to make system binaries? I have very limited knowledge of ASM and OS architecture, in case that sounds dumb. I'm just trying to implement these functions in x64 assembly. Yeah, replace hello world with what the test has. What did the test have? It's I guess I can just go read the test, no? This guy. Hey, you know what was different this time? I didn't change the shebang, and maybe that's why it worked. I have no idea though. Test. What was it? It was print string. Test print string. Here's the input. It's this. Output, input. What's the output it's expecting? Okay, so let me just yoink that, and then okay, I need to recompile this. So -f 64. What is it? Print stir. I mean, that seems to work to me. Setting a new line because I had a new line here, but if I took that out, then it takes out the new line. Right? So problem comes from how the test expects the code to be written, you think? What makes you... Does clobber mean like overriding a register when in a function call? Try starting the function with push. Restore the base pointer. This one? Oh, that's what clobber means. Okay. Try starting the function with push RBP, move RBP, RSP. What? RBP? Why RBP? Where's my table? The frame pointer. It's also stack alignment to be considered. There's a lot to be considered. I wish I could isolate tests. Anybody know if there's a way to isolate tests? Like just test one of these things? Well, I guess they like depend on each other, don't they? It does complain about that end calling convention. It complains about a lot of calling conventions. Parse int. Test print string. Test print string, right? Print string. Look, so print string, where's the, maybe this will be helpful. Print string is supposed to accept a pointer to a null terminated string and prints it to standard out. So I assumed that meant accepts a pointer in RDI. Let's see if in the test it's assuming it takes it in RDI. Sure enough, it moves the pointer of the string into RDI, and then it calls print string. So then we have it in RDI. Not that, where am I? We're expecting it to be in RDI because then we call string length, which also expects it to be in RDI. Right, and then we move, is it that we're supposed to restore some of these? RDI, I can use freely, it might be changed. Alright, anything else I'm messing with? RAX, I'm allowed to change. I'm changing RSI, which I'm also allowed to change. And that's it. RDX, which I'm also allowed to change. So I'm only changing the ones I'm allowed to change. Unless it's in this one. I don't think so. Endcraft. Hello. What did you miss? I forget exactly when you left. But we are running the Python tests now again because we didn't really understand the instructions. So now we're doing this. And we got lots of failures. And we're trying to figure out why test, like why some of these are failing, even though this seems like they should be working. Like print string we're looking at. It's failing with this. But seems like it should be working. some sort of stumped. Add any push op before call string length and then pop it after. We just like push like this. Why though? What does this do? Lorem ipsum. The basic idea is that you should have odd amount of 8-byte words on stack before call, or when it adds up with return addresses. You get 16-byte aligned stack upon entering the procedure. Not sure I totally get that. Is it just me, or is print string not failing anymore? What? It seems like pure wizardry. No, I have not made my own kernel. Wait, so you're telling me this worked? I'm not seeing any failures for print string anymore. Can somebody explain? So you said the basic idea is that you should have odd amount of 8-byte words on stack before a call. Oh, when it adds up with return address, or when it adds up with return address, maybe you get 16-byte aligned stack. Now try to do my push RBP stuff. It's a typical prologue you will see in real functions. Let's try Stephen. All right, you said try starting the function. So instead of this, right? You said try starting the function with push RBP, move RBP, RSP, and then end it with pop. Sorry. Pop RBP down here. Author this book sent your stream to students. Crazy. That is crazy. That's cool though. All right, this is right. Stefan, can you confirm that this is the incantation you wanted me to use? I'm gonna try it now. Test.py. Here we go. And okay, we got print string is failing. It appears to have not worked. Test print string failed. Why do I have a semi? Oh yeah. Wait, let me just verify. When I test it. This is so hard to read. Wait, now it's gone. What? Parse int, parse uint, print int. Oh yeah, print string right here. Okay, so it failed. But when I do it with the other way, which was this. Then it used to work. We got parse int failing, parse uint, parse print int, print uint, read char, read word. Yeah, these are all different. Yeah, so it's working this way. So can somebody, is anybody able to explain to me why I had to do that? Let's see if I can get this guy to tell me. I'm writing x64 NASM. I'm running some tests on my functions I'm writing. This passed, and it was this, right? Yeah, not that. Oh, I forgot. I cannot copy to the system clipboard from here. But when I removed the push RDI pop RDI thing, it failed. Why does it make a difference? Assuming you can read this. No, that's not at all the answer. Okay. So sorry, let me refresh this here. Hey, it's Igor himself. If you recall correctly, tests simulate the case when string length or any other function is clobbering the registers. Yeah, welcome, Igor. Igor, am I saying that right? Igor or Igor or I don't know. I don't speak Russian. According to the calling convention, the functions you are calling have a right to use and not restore most of the registers. Igor. Okay, cool. Thank you. So the test injects something into internal function calls, except for RBP, RBX, and R13 through R15. So why? But RDI, so my question, like this one in particular, RDI is something I'm allowed to change, right? I'm allowed to clobber, I think is the terminology. Right, where's my chart, right? RDI, I can clobber it, right? And so the only thing I changed here to make this work is I added this, and I'm trying to understand why, like, the push pop thing before this call makes any difference. Oh. You're saying because the test simulates the case where this. Oh, okay. I think I get what you're saying. So you're saying the tests simulate the case where this function call, because this function call is legally allowed to clobber RDI, right? And so it's simulating the case where it does within the tests. And so me preserving RDI by pushing and popping it saves that. Okay, exactly. Okay, that totally cleared it up. Thank you so much. I get that now. But technically speaking, this particular function, no, that's not it. Where's print string? Yeah, no, this is it. String length. This particular function doesn't actually change RDI, but it just simulates the case because it could. It could have. I could have. Gotcha. So just kind of enforcing good practice. Xylo was the one deleting all the elephants the other day. Now he's the one sending them. All right, we all converted. Cool. All right, thank you so much, Igor. That's cool. So now what else is failing? Next failing thing. If you don't respect the conventions, all your subroutine becomes fragile. Suppose in a year you change the implementations of string length and now it actually overrides RDI. Exactly. Now all the callers of string length are broken. Gotcha. That totally makes sense. So it's just the kind of thing I need to look out for anytime I'm writing a function, just for good practice, regardless of whether I technically actually do clobber something. All right, let me see. Yeah, what else is failing here? Correct. Cool, thank you. So this one I just haven't written yet. This one I haven't written yet. This one I did write and it's failing. Okay. All right, looks like well, what else is failing? This one's easier to test. I was supposed to get this, and I got nothing. That's discouraging. This one I haven't done yet. This one I haven't done yet. String copy. This one I haven't done yet. This one I haven't done yet. Okay, so the one I've done that is failing are these two, print int and print uint. So print uint is simpler, so we'll start with this one. For some reason, this guy I wish the one thing I do wish these said which function this warning is coming from, because like it looks like 3 of my functions aren't respecting the calling convention, or in 3 of the tests that's happening, but I don't know which ones. So probably one of these ones that's failing now. So print uint. Let me go back to the. Okay, it accepts a null terminated string and tries to parse that's parse uint. Print uint is this one. Outputs an unsigned 8-byte integer in decimal format. Okay. Maybe comment them all out. Good idea. Very good idea. But then they all start failing if I comment them out. Actually, if I comment them out, it'll probably just give me errors because it can't find the names in the assembly. So I don't know if that's gonna be the cleanest. All right, let's just take a look at where is print uint, this guy. So it takes, what does it take again? Okay. Oh, you know what helped was when I where's test.py? not that one. This one. Test print uint. So we input all these things. It's interesting that it's inputting a -1 when this is an unsigned int. But it's kind of cool because it's expecting this, right? Although where is that even written in this file? It's not written anywhere. Maybe it's one of these functions in here. I don't know. Can I know which kernel you are using? And I'm sorry if my question bothers you. No, question doesn't bother me at all. Sorry if I missed it before. Which kernel am I using? Like, which operating system am I running all of this on? Is that what you mean? This is on a GitHub code space, which is Linux kernel, Ubuntu, I think. But locally I'm on Mac. Is that what you mean? Not sure what you mean. Passing -1 successfully, I'm guessing. I'm just checking this convention. So it's sticking RDI. Oh, it's sticking the input into RDI. Okay. So that's what we want, like directly into RDI. Is that what my function is expecting? Yeah, it looks like it. And then we print, and then we exit. Oops. So mine says, okay, move RDI into REX, yeah, and then guess the call to print char is the problem, like down here, because it's clobbering stuff. Very well could be. In every iteration, the registers are clobbered. Yeah, so how do I do I want to, like, do I need to do the push pop thing for every single, yeah, do another push pop around that? That makes sense, but like just for RDI, or do I do it for every single clobberable register? Because there's a handful of those, aren't there? And so, like, why was it fine with me only preserving RDI above, like in that other one, but not like the other ones that are clobberable? Everything I depend on. So everything I depend on in here. Okay. So like push RDI I do depend on. Also, like what else? Like all these RDX, RCX, RAX. Well, I want, yeah, I depend on all of those. How many of those are clobberable? I like this new clobber terminology. It's funny. So I'm using, for example, RDX, which is clobberable. I'm using wait, that was RDX. This is RCX, which is also clobberable. RAX is clobberable too. Those are all clobberable. Do I need to do all of them? I don't know. Adding to the stack pointer. Doesn't the stack read out? Add RSP8. Yeah, why would adding to the stack pointer help there? So I guess I'll try preserving all these registers that I'm using. Right, so push RDI, RAX, what else am I using? RDX, push RCX, right? I'm using all of these. And then I need to pop them off in reverse order. So this becomes that, this becomes that, oops, that becomes, wait, that. RDX, RAX goes here. All right, who knows? Look for print uint now in the test. See if it works. Test print uint, sure enough, is not working. Same error. So it almost seems like we have a logic error, not like a call stack error. Also a little bit, still not sure about this, because I feel like this seems like a lot. If I have to do this every single time I call a function. Maybe that's just how assembly works though, I'm not sure. All right, not sure about all this. Even amount of pops and even amount of pushes yields unaligned stack on call. You saying I need to do an odd amount? Like not do this guy? And hope for the best? Seems a little bit arbitrary. Just, yeah, it's still failing. The output changed, did it? Oh. It did change. Hold on 1 minute. Good catch, Astro. Okay, but that was like a totally arbitrary choice. I just chose one of those registers randomly. Like, what if I did a different one? Like this one, RDX. Like, surely there's a method to this madness, but I just don't understand it. See, that also yielded the same. Like, would it yield the same if I also just did RDI? Who knows? Yeah, it does the same if I just do RDI. But then if I don't do the RDI, then oops. Then it has the empty string. And if I did two different things, wait, so undo that, undo that, undo that. If I did two things, like say RCX and RDI, then it goes back to this. So there does seem to be something to the whole even and odd amount of things. Because like an odd amount is working and even amount isn't working. But I have no idea why. Yeah, what sorcery is this? That's what I'm saying. Totally confused. I get what Igor was saying. Made sense to me. Like about following calling conventions and making sure it doesn't clobber things. But this whole like even odd arbitrariness seems. Try to store all registers and some extra space using sub add. So if I understand correctly, for -1, it should output an overflow. That's what the test is expecting. I think it's that Isn't it that if I have -1, then that's in binary, that's like all ones, which is some huge number? Because I don't know that it's signed. Isn't that what it is? Because it'd be like 0, 0, 1, and then you take like the invert all the things, and then you add 1, and you get all ones, right? And then this becomes some giant number, right? I think that's it, but I'm not sure. All right, this is oops, sorcery. So the way I see it now is that push and pop is working, but the function logic is not picking up the negative symbol, maybe. You need to push and pop everything you depend on. If that turns out to be even, then sub from RSP another 8 bytes and add them again after. That if it turns out if stack alignment is important. What is stack alignment and why is it important is my question. So okay, so you're saying I need to do all my things. I need to do RX, I need to push RCX, I need to push RDX. Is that all of them? And then you pop them. So pop RDX, pop RCX, pop RAX, pop RDI. Now this turns out to be even, so we're gonna each RAX, RBX, etc. register push is 8 bytes, yes. The odd even thing keeps the stack at a 16-byte alignment. If you need an odd number of pushes, it's probably because the function call pushes the return address. Can you look up what Google says about assembly stack alignment? It should help to understand this concept better moving forward. Good idea. Let me just try this like the subtracting from the base pointer and stuff. No, the stack pointer, not the base pointer. All right, you're saying this turns out to be even, so it's not going to work. So I need to sub from the base or stack pointer 8 and then add again. So add 8 here. All right, I'm a little doubtful, but let's see it. Sure enough, we're getting the 1 again, which is the closer to working thing, right? Okay. Super weird. Still feels a little bit like sorcery, but also feels like it's starting to maybe clear up a little bit. So you need to preserve everything you depend upon, which makes sense. And then if it turns out to be odd, then you probably have to do this too, just to bump it over 1 more. Okay. Let me, you said assembly x64 NASM stack alignment. I think alignment is only important for reading writing 16-byte values, so it doesn't really matter for a regular read write. And if it was unaligned, and then it would just throw a seg fault, I think. What's wrong with this? All right, stack overflow. Here we go. How does stack alignment work in ASM64? When do you need to align the stack before a function call, and how much do you need to subtract? I didn't understand what was the purpose of it. I know there are other posts about this, but it wasn't clear enough for me. For example, all right. For example, extern foo, global bar. Okay, here's bar, some code. Then you align. Okay, y8. I saw this on some posts. Can it be another value? Why can't I scroll? Why do we need to subtract? Do we need To align stack every time we call a function? Oh, this is like all my questions right here. Oh, perfect. This is great. This better be a good answer. All right, here we go. Why do you need to align the stack before a function call? And dot dot dot. Okay. You need to align the stack when the function you're calling expects an aligned stack. Functions that were written in other languages, like C, and functions that are written in assembly but are designed to be called from other languages, will comply with some kind of calling convention, which includes much more than just stack alignment. However, parameters are passed, where parameters are, things like red zone, etc. Okay. And for 64-bit, the two common calling conventions expect the stack to be aligned to a 16-byte boundary. Okay. In a pure assembly project where you're calling functions that are written in assembly for assembly callers like me, the programmer is free to do whatever they like, whatever is best for the performance, without caring about the limitations or restrictions of other languages that reduce performance calling conventions. In this case, you may never need to align the stack at all, but if you're dealing with whatever this is, a function might want the stack aligned to 64 bytes, and if you're dealing with this, a function might want the stack to be aligned to 32 bytes, and dot dot dot. Okay, so forth. How much do you need to subtract? And if you don't know if the stack was aligned enough, then aligning the stack is typically done with and. Maybe and this, okay. Why? To align the stack to 16-byte boundary. The sub thing seemed simpler, didn't it? This also means that you need to store the old stack pointer somewhere so that you can restore it. Okay, so if you do this, then you have to like push. Hey, this is what Stefan was saying, which often means 4 more instructions. This before alignment, then that to restore things later. Okay. However, if you know that your caller align the stack for you and that functions you call want the same or less alignment, then you can calculate how much extra to subtract by keeping track of how much you push on the stack. For example, if the stack was aligned to 32 bytes by your caller and you push 4 64-bit 8-byte values on the stack, and a call instruction will push another 64-bit value return address, then it'd be a total of 5 times 8 equals 40 bytes. So you know you need to subtract another 8 bytes to make the total 48 bytes if you want to align to 16 bytes, or subtract another 24 bytes to make the total 64 bytes if you want to align to 32 bytes. Alright, that's a lot of numbers. But I think I get the general idea. This also avoids the need to save the original stack pointer. Sure, so you can save 4 instructions. Yeah, okay. Of course, for pure assembly, you'd look at the requirements of all the functions you call and pick the worst case and align the stack to that once, and avoid aligning the stack multiple times differently, once for each function you call. And you might say, my function requires the stack to be aligned to whatever the worst case is for the functions I call, to ensure that you can calculate how much to subtract and avoid the more expensive and with approach. However, for pure assembly, this places the burden on your caller, who may place the burden on their caller, who may, so on. So it can make performance worse. All of the ancestors in the call chain have to do extra work so you can avoid less work. In other words, for pure assembly, achieving the highest efficiency / performance takes a lot of work to determine if one stack should be aligned by how much, and minimize the expense of ensuring stack is aligned where necessary. This is also part of why compilers put the alignment in their calling conventions. A required, unlikely to be optimal most of the time, standard alignment makes it easy for the compiler. Okay, I think I get it. More or less. What I don't totally get is why my print char expected the stack to be aligned. I don't really know. And RSP, that will clear the lower 4 bits, a value in the range of 0 to 15, which rounds down to a multiple of 16. Kaya, see what I sent over in Teach Kaya. Teach Kaya. Cool, you sent me a link. This guy. No, not this one. This, what one is it? This one. Cool, I read that. Let me just finish reading these comments real quick. Basically, the underlying reason for the 16-byte boundary is because copying large chunks, as large as the CPU hardware is capable of, is much more efficient than copying single bytes. Sure, okay. Ling needs to go eat dinner. I haven't even eaten breakfast yet. All right. This was recommended me by Stefan. We have, all right, when compiling below code, using this is sort of similar, and then run that. It runs, but then crashes and prints seg fault. You said ignore the seg fault part. It's not important. See the first answer. Okay, here's the first answer. Use that at the start end of your function to realign the stack to 16 bytes before your function does a call. This is what we've been doing, right? Oh wait, comment. Maybe the test framework wants alignment, not your own code, just like with the clobbering. Problem is relevant. See the first answer. Yeah, I'm looking at the first answer now. That okay, endcraft. That's a good point. Maybe just like the clobbering, it's a framework that wants me to be aligned. Okay, so we've been doing this. Yeah, we did that. Or better, push pop a dummy register. We also tried this. Or a call preserved register like RBP. You actually want to save anyway. You need the total change to RSP to be an odd multiple of 8, counting all pushes and that, from function entry to any call. Gotcha. Yeah, that's what we figured out. An odd multiple of 8. Odd multiple of 8. And pushing a register. Registers are 8 bits, so that counts as 1. But so does subtracting or adding 8 to that, right? So on function entry, the stack pointer is 8 bytes away from 16-byte alignment because the call pushed an 8-byte return address. See this and this. This is an ABI requirement which you used to be able to get away with violating when there weren't any FP args. Okay. Put another way. That modulo 16 should be on function entry, and you need to ensure that is 0 before you call a function. How you do this doesn't matter. Okay. Not all functions will actually crash if you don't, but the ABI does require a guarantee it. What does ABI stand for? Application binary interface. Okay. This is super interesting. Okay, so I think that's the most of it there. Application. Thank you, Mr. Nibbles. Okay, I got a question now. So you know how it says when you enter a function, you're off by 8, right? From being 16 aligned. And then when you call one, you need to be exactly 16-bit aligned, right? Or 16-byte aligned, right? 16-byte aligned, but then when you enter, so something happens between here and here when you enter a function that causes it to get off. And my question is that because it pushes the return address onto the stack? Is that what does that? Because I think that would make sense to me. Like if we had if this is memory and you got like a spot here and you have a spot here and a spot here and a spot here and a spot here and a spot here, then these are like all 8 bytes apart. Then the 16 ones would be like here, here, and here. So you need to be on here, right? And so when you enter a function, you need to be here because then it's going to push onto the top of the stack here the return address. So you need to make sure you're here. Is this correct? And then if I'm from in here, I'm going to call another function. I need to make sure to get up to here. right? Because it'll start me out over here when I get the next return address. Does that make sense? Yes, every time you call print uint or any other function, that call pushes the return address. Okay, and that's what offsets you by 8, which is why you need to be aligned when you start. This is super fascinating. Cool. What function were we in? Oh yeah, this guy. So we did all this. It was even. We need to be aligned, and so we do this also. We could have also used the dummy register trick, but I like this. This is nice. Awesome. All right, 7:47. I was kind of planning on going to 7:45, so I think that's probably a good stopping point. I'm gonna stop it there. Next week we need to, or not next week. Well, yeah, next week. It is Friday, right? Okay, I should. No, it's Thursday. Sorry, forgot to mention. I'm not gonna be able to stream tomorrow. Tomorrow's Friday. I'm leaving actually like this morning. I'm going out of town, and so won't be streaming tomorrow. But I'm hoping to be back on Monday, and probably normalish time. But I'm gonna leave this here for now. Thanks everybody for the help, and I learned a bunch today. See you guys Monday and on Discord. Bye bye.